Great mathematicians, we are now experts, or at least getting there with our finding area of parallelograms. Now, what about triangles? So, we still are going to use what we know about a rectangle and a square. So, and really a parallelogram too. This is where we can start to think about every single square, rectangle, and parallelogram can be chopped into two. And what shapes do they make? Two triangles. Two triangles. Yeah, I could even have gone that way. I could have gone that way. But it makes two equal triangles when I cut it like that. So thinking about a area equaling length times width for a rectangle or a square, an area for a parallelogram being base times height. When we're looking at a triangle, we run into that same situation where we have not complete units. So what we can do is think about, well, how could I complete these units to be able to count it? And what mathematicians discovered is in order for this to work for every single triangle, we can simply just think of this. You can mark this with me. So I'm going to go all the way across 1, 2, 3, 4, 5 units because I went all the way to here. And then down 1, 2, 3, 4. If I complete that rectangle, I now have complete units. But notice the shape I actually need, my triangle, is really half of what I just created. So what we can do is we can use, and we have a perpendicular, we have a right triangle, guys. So with a right triangle, we already have a nice height, 1, 2, 3, 4. We have 4 units, and we have a bottom or a base that is 1, 2, 3, 4, 5. Let's, for fun, let's call these inches. Units are no fun. Let's call them inches. And, well, I can do base times height, just like a parallelogram. However, I don't have a parallelogram. I have half of one. Isn't every rectangle also a parallelogram? So I can use what we know about that to figure out our formula. So if we do base times height, that's not going to work. That's 20 for all of it. But we don't have all of it. We just did this imaginary section that makes a rectangle. So what we have to do is we need to get rid of half of it. We can do that in a couple different ways. I just said half of. So half of, remember that word of means multiplying and half. So in this case, we would have a base of 5, write this with me, height of 4, and then multiply by half. Showing all of our thinking, of course, in what we thought each number was. So we would have, and you could tackle this anyway because it's all multiplication. You can do the half of 4, you do 5 times 20. My reading eyes just have me going left to right, but sometimes I'll do this just to make the number smaller if I need to. So just know you have the option to do half of this number first if you want. So I have 20, and half of 20 is, I can do that mentally, but still right in my thinking, 10. Because we got it back down to its triangle. 10 inches, I know, squared. We got to square it, right? So this was with a right triangle. And how would you classify the sides? Because it was a 4 by 5. That's definitely not the same. This would be scalene. So it's a scalene right triangle. Let's see how this formula works for this triangle and how it is made. So this time we don't have a right angle, and we know we need a height line with making a perpendicular line. So it's kind of like the parallelograms where we can make a height line. Sometimes you'll see it off to the side. Sometimes you'll see it right down the middle. Now, when I say down the middle, it doesn't mean it's precisely down the middle. We'll see kind of this imaginary line like before, and we'll even see that 90 degree in there. Go ahead and make that. And because we're on a coordinate grid, we can count our height units just like we did here. So again, this is like your mountaintop, right? The height is not you hiking up to the top. It's sea level to the how far it goes up in the sky. Okay? Standing up straight. It's the straight perpendicular one. So our height is 1, 2, 3, 4. And for fun, let's call this centimeters this time. Just keeping you on your toes here. And then what would our base be? It's still the same concept that our base would be down there below. And we have it 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Oh my goodness, it's the exact same as that one. Didn't even plan that. So with our formula, we can say, all right, the area is going to be, and here's another, I'll show you eventually some other ways to write it. We have our base times height times half, and 5 times 4 again. So I'm going to show you this time now that we have the same one. I could do half of 4, which is 2 multiplied by 5, and you still get 10. 10. See, that's what I was trying to throw you. It's not inches. We get in a groove with our labels, and that would be completely wrong on the test. So make sure you have centimeters now, like I do. Okay? What kind of triangle was that? So that's tricky because we don't have the dimensions for the sides here, but we can kind of tell since it's on a grid. We can't say that this is 5. We have to really just eyeball it. It's looking like it's scaling to me. And that's by its sides, but how would you classify it by its angles? If it has 3 acute angles, it is an acute triangle. What about this one? What do we have here? Kind of looks, well, by its angle, what would you say? Definitely obtuse, because we have that one obtuse. Remember, every triangle has acute angles, but it's only an acute triangle if all of them are. So this is obtuse because it has one obtuse. All right, how are we going to get our height line here, do you think? This is an interesting triangle. I can't really go up inside of it as easily. Even I've had people do this before, and you still can't measure that, right? You don't have the grid. The grid doesn't. You can't count that. No, it's like 1.5. You don't know that. You can't tell, but you can if you cut it along the grid. So hiking up the hill. Nope, that's not the height. The height is from the base perpendicular up. Here it is. There's that 90 degree. I can extend that there and put it on so it shows that perpendicular line to give us our height. 1, 2, 3. Oh, yay, it wasn't 4 this time. Still keeping me on my toes, apparently, not just you. Let's call it feet. Now, be careful. You don't use those numbers that are over here. And typically, if it's already given to you, it wouldn't be there. So for us, since we have to count it, we're counting these. 1, 2, 3, 4. So this another 4. Goodness. All right. So we have a base of 4 and we have a height of 3. So area equals base times height times half. And the base is 4. The height is 3. So this is the time where I'm not going to make my life harder and do half of 3. I could do half of 4 still. I can mix it up. But I can also just do 4 times 3 and easily do half of 12 and get 6 feet squared. Okay. So if you remember parallelogram, base times height, a triangle is half of a parallelogram. So you can always remember the formula for a triangle. Now, let's see all these different ways. So record these with me. Well, let's record all of the words like we did with parallelogram. Area equals. Now you can definitely put these in any order. But so this time I think a lot of times you'll see the half is written first. So I'm going to write it first here for you guys. And then it's times base times height. All right, so let's look at all the different ways we can use these variables and in symbols in writing this formula. So we could have A equals half, and then you could have the times B times H, right? You could also have it without the symbols. You could have half, and that still means times, right? Numbers or values outside of variables, it still means multiplying. And then you could even just do the H there. You might see it like that. So, and it could be mixed up. Like before we were doing base and height and half. So that's why I always encourage to write down the formula, and then you can show your numbers that go into it. Okay. So if you flip your paper over to the back, we have some other demonstrations for you as well. So if you have two triangles, you can put them together and you always get a parallelogram. And with those, you can get your height. So they put theirs right there. You could even have done it right there. So showing those different dimensions. And another model of it is that if you have the area of a parallelogram, like we just showed before, base times height, then we can also get that of a triangle by just taking half of it. I want you to write down a little reminder though first. This half is the same thing as timesing by half is the same thing. So let's put equals, dividing by 2. So if the numbers are more friendly for you to think of it as dividing it by 2, you could use that as well. Okay. They even put parentheses around the base and the height, which you don't have to do because it's all multiplication and the order of operations aren't really needed there then, right? All right, let's see if I trick you on this one. I have numbers you may or may not need again. So they're talking about, marking up this question here, a flower garden in front of Hilldale School. Oh, how nice. It's in the shape of a large triangle. It is shown at the right. What is the area of the flower garden? Show your work, show your thinking. Okay, so I know if I'm finding area, I'm going to have half times base, give myself space by putting those symbols in. Which one is the base? Which one is the height? What do you think? What do you think? We got a few numbers to choose from. All right, let's see how you did. I see a base of 10. Don't forget your half. And I see a height of 8. How'd you do? All right, so this is where you can kind of pick and choose. Oh, that's an easy 80, but I'll do a half times 5 or 10 because it's nice, easy 5, and 5 times 8 is 40. I have an area of 40. Went back to my shape to see my symbol or my label and meters squared. All right, and the reason all of these extra numbers are here is because for this next question. So we want to know the perimeter of the flower garden. It's a very typical type of situation. If you are filling in the garden with dirt, you would need to know the square footage because that's how you would buy the dirt or the mulch and things like that. And then if you are putting like a fence around, you would need to know the perimeter. Or sometimes you might put different types of structures to hold in the dirt so it doesn't spill all out. So perimeter is the outside of the shape. What numbers are we going to need for the perimeter? All adding up all the sides, right? Should have done 17. We actually need that one this time. Plus, so we got one outside line, 10. Plus, which one now? Not the 8. The 8's a height line. We need 9. Okay. So these are pretty easy to kind of mentally do, but I'll show my thinking. I have 27, and then I still have my 9 to add. So I'm going to have 36. 36 is my perimeter, and how we label it. No squared, it's not two-dimensional. Okay, just meters. All right, that was our practice together. Now you're ready to try some on your own. All right, get after it.